Hello friends, welcome to online school, and now let's talk about differentiation of trigonometric functions. And then trigonometric functions, these ones, they have various formats or categories. So you have trigonometric functions with single angles, and then these include or take examples like y equal to sine x or y equal to cos x. It could even be tan x equal to y. So those are equations with trigonometric functions with single angles. And then we also have multiple angles, like take an example y. This case will equal to sine 2x or sine 3x. And then we can also have y equal to cos 3x. So then we can also have many more equations of that format. So these are trigonometric equations, but with multiple angles. Say that these ones are single angles. And then so we also have trigonometric functions with higher powers, and then these include y equal to, it could be cos squared x, it could even be y equal to sine squared x, like that. So now these are the formats of trigonometric functions, and then we are going to be covering one by one. And then so let's start with differentiation of trigonometric functions by the functions of single angles, and then we are doing this from first principles. So we are going to be following the previous steps that we mentioned in the first part. And then we said that, take an example, if at all we have our function y equal to sine x. Note that this is a trigonometric function, but it's in single angle form. And then so what are the procedures? We have the first step as you first add small changes to both our variables y and x. So this one here, it is going to be y plus change in y will equal to the sine of x plus change in x, like that. And then so take note here that we add the change in x to the x variable. So it should not be in this way around, sine of x plus change in x. This is completely wrong. So it should not be in that format, but rather it is y sine of x plus change in x plus change in x in brackets. And then so let's proceed. So the next step was that you subtract the two equations, and then for that case we shall have y plus change in y minus a y, this y here, it is equal to sine of x plus change in x minus sine x. So now here we can, this one here can simplify to change in y equal to sine of x plus change in x minus sine x, like that. And then so when we reach this step, we can divide through by the change in x. But then before we divide through by the change in x, let's first look at this knowledge from trigonometry that we are going to use to proceed from that step. And then so we know that from trigonometry we have what we call factor formulae. So in this case we are going to apply a factor formulae to this expression here. And then so we have that from factor formulae that sine of an angle say alpha minus sine of an angle say beta. This one here, it will give us 2 cos of alpha plus beta divided by 2. Then sine alpha minus beta divided by 2. And so other formats of factor formulae, we have sine of alpha plus sine of beta. This one here, it gives us 2 sine alpha plus beta divided by 2. Then cos alpha minus beta divided by 2. And then so we also have cosine of alpha minus cosine of beta being equal to negative 2 sine alpha plus beta divided by 2 sine alpha minus beta divided by 2, like that. And then so we also have lastly cos of alpha plus cos of beta. This one here, it gives us 2 cos of alpha plus beta divided by 2, then cos alpha minus beta divided by 2. So this is what we refer to as factor formulae, and it's what we are going to be using when it comes to differentiation of trigonometric functions from first principles. And then so let's proceed. So in this case here, you happen to note that if at all we have our x plus change in x as our angle alpha, and then we have our x as our angle beta. So in this case here, we shall take the first scenario, this one here, sine of alpha minus sine of beta equal to 2 cos alpha plus beta over 2 sine minus beta over 2. And then so let's proceed here. So we shall have change in y equal to sine of x plus change in x. Remember, it was, or let's use this other form. Let's use factor formulae. And so from factor formula, we shall have 2 cos change in y, it will equal to 2 cos of alpha plus beta. But then in this case, it is going to be x plus change in x plus x plus change in x plus x, the whole of this here divided by 2. Then sine of x plus change in x minus x divided by 2. And then so this is what we have now after applying factor formulae to our expression. And then so how would we proceed with this? Now you happen to note that this is x plus x, it can get to 2x plus change in x over 2. And then this is x minus x, we can only remain with change in x over 2. And then so let's get to that. So we shall have change in y equal to 2 cos of 2x plus change in x is 1 over 2. Then sine of change in x divided by 2. And then so at this step here, we can divide through by the change in x to have change in y over change in x being equal to 2 cos. Now you happen to note that this is 2x plus change in x over 2. It is the same as x plus change in x divided by 2. Then we also have sine of change in x divided by 2. The whole of this expression here divided by the change in x, or like that. And then so what's next? Remember that we know that dy dx, which is our derivative function which we are looking for, is equal to the limit of the change in y over change in x as the change in x approaches 0. And then so we are going to substitute for change in y over change in x at this part here. And so we shall have our dy dx being equal to the limit as the change in x approaches 0 of 2 cos x plus change in x over 2, like that. Then sine of change in x over 2. And then remember you have this, the whole of this divided by, all of this is being divided by a change in x. And then so what happens when we are taking the limits? So you note that whenever we are taking limits, we know that sine of a small angle in irradians, we are taking this change in x over 2 to be our angle. But then so this is our angle, but it's in radians. So there is this property from trigonometry that sine of a small angle, say theta, in radians is approximately equal to theta. So now this is a property from trigonometry. And then so if I told you you're not well conversant with trigonometry, you shall also have a video about that topic. And then so let's proceed. Knowing that the sine of a small angle in radian is approximately equal to that angle. So now from this expression here, remember our angle is change in x over 2. So let's try to make this to be change in x over 2 such that we take the limit of sine of change in x over 2 over change in x over 2. Because we know that sine of a small angle like theta, it is approximately equal to theta. But then here we have change in x over 2, and then this is change in x. So to take the limits easily, we can make this to be change in x over 2. And then so we shall have the limit as change in x approaches 0. And so you happen to know that here we have a 2. And then so what you do, it's like we are multiplying a half in the numerator times the a half in this denominator here. So what are we going to get? Remember this a half here, to reduce this 2, and then we shall remain with cos of x plus change in x over 2 sine change in x over 2, like that. And then so remember we have the 2 here next to a cos being reduced. So we shall have this as change in x over 2. And then so having such an expression here, remember this is sine change in x over 2, and then this is change in x over 2. So when we are taking the limits, we happen to find that the limit of cos x plus change in x over 2, as this happens to get much smaller, we shall only remain with cos x. And then for this one here, the limit of sine change in x over 2, this being divided by change in x over 2, as change in x approaches 0, the limit of the whole of this expression is it is a 1. And then so we shall have a 1 multiplying cos x, and then so we shall remain with dy dx. So we shall remain with dy dx equal to cos of x being multiplied by a 1, which will make it remain cos x. And then so by so doing, we have found our derivative function to a function y equal to sine x. And then so in the next video, let's try to work out the one of cos x. Remember, now here you can conclude and say that when you differentiate sine x, you get cos x, and cos x is a derivative function. So let's get to how to differentiate another single angle. Let's try out the one of cos x.